Good morning, everyone. I am Uma Maheshwari, AP Triplet Department. So, in this video, I am going to discuss about the subject High Voltage Engineering. The subject code is E8701. And in that, the discussion of the unit is Unit 2 Dielectric Breakdown. So, in Dielectric Breakdown, today's video session is about the Townsend's second ionization coefficient process. And what are the mechanism of producing the additional electrons in order to create an avalanche effect is, so due to the positive ions, we are able to generate few more electrons when this positive ions impinge on the cathode material. And due to the excited atoms in the avalanche, during the process of traveling from cathode to anode, they emit photons. So due to the photon emission process, this emission of electrons takes place. So the excited particles or metastable particles may diffuse again and causing the electron emission. The Townsend's second ionization coefficient is represented by the symbol gamma. The number of secondary electrons produced per incident positive ions, photons, excited particles or metastable particles, and the total value of all these is known as Townsend's second ionization coefficient, which is represented by the symbol gamma. Now, the N naught dash represents the number of secondary electrons produced due to secondary ionization process, and N double dash be the total number of electrons leaving the cathode. So this N double dash, number of electrons leaving the cathode is equal to N naught dash plus N naught. N naught is the number of electrons generated due to photovoltaic effect. N naught dash is the number of electrons generated due to secondary ionization process. Whereas the N represents number of electrons reaching the cathode. So according to Townsend's theory, N is equal to N naught double dash e power of alpha d. Substitute N naught double dash as N naught plus N naught dash. So you get the expression as N is equal to N naught plus N naught dash e power of alpha d. Now, the number of electrons released from the gas is given by N naught dash. N naught dash is the number of electrons due to secondary ionization process, which can be given as N, number of electrons reaching the anode, minus this total number of electrons due to this emission, that is N naught plus N naught dash. So the N naught dash is given as multiplying by the Townsend's second ionization coefficient alpha on the RHS side. So N into alpha minus N naught into alpha minus enter inside, and then minus N naught dash into alpha. Now this N naught dash into alpha is taken to the left hand side. So, and taking that N naught dash common out, it is given as 1 plus lambda, which is equal to taking lambda common out, alpha common out. So this taking this notation common out, it is N minus N naught. So N naught dash, bring this term to the denominator. So it is gamma by 1 plus gamma N minus N naught. Now eliminating the N naught dash. So here this N naught dash, it is substituted here. So it is substituted in this N equation. So N is equal to N naught plus, instead of N naught dash, this entire equation is substituted. So it is N naught plus gamma by 1 plus gamma into N minus N naught into e power of alpha d. So now this, in this expression, taking the LCM, okay, as in denominator LCM, so it gives N into 1 plus gamma, which is equal to N naught into 1 plus gamma plus gamma into N minus N naught e power of alpha d. So N plus N gamma is equal to, so multiply, remove the bracket, N naught plus gamma N naught plus gamma N minus gamma N naught e power of alpha d. Cancel the positive and negative values. You get the expression N naught e power of, multiply the e power alpha d inside plus gamma N e power of alpha d. In the and then take the term which is common in gamma to the other side of the expression. So N, okay, when I take the N common out, becomes 1 plus gamma. When I bring this term to the other side, it becomes minus gamma e power of alpha d, which is equal to n naught e power of alpha d. Now bring this term to the denominator. So I get the expression n as n naught e power of alpha d by 1 plus gamma minus gamma e power of alpha d, which is equal to n naught e power of alpha d by, I'm taking the gamma common out. So I'm taking minus sign common out. So gamma into e power of alpha d minus 1. So this n can be represented in terms of current because the number of flow of electrons is nothing but the current. So n is represented as I and n naught is represented as I naught. So the total average current in the gap before breakdown is equal to I naught e power of alpha d divided by 1 minus gamma e power of alpha d minus 1. So this is the current expression for second ionization process. Thank you.